A simple and straightforward dynamic programming algorithm by using the k elements in the k-dimensional edit graph will result in the multiple sequence alignment. So for example, if we have the three sequences U, V and W, then we will use the same strategy as we have used before for the Manhattan-like edit graph, in which there were only two dimensions I and J. So in this case we have the three dimensions I, J and K. So for get to the vertex I, J, K in a three-dimensional edit graph, we can come to the point of the vertex I, J, K by using any of the following predecessors. Here we can see here that if before we use the Manhattan-like edit graph, that was only in the two-dimensional, but now we will use the three-dimensional edit graph. This is X, Y and Z dimensions. So by using the X, Y, Z dimension, we will solve this multiple sequence alignment of the three sequences. So we have discussed earlier that we can get to the vertex I, J, K in three-dimensional edit graph from any of the following predecessors. Number one is, we have already seen in the Manhattan edit graph that if we have a I minus 1, it can move in the south direction, and if we have a J minus 1, then it can move in the east direction. So by using that instructions, we can use the three-dimensional edit graph. In this, first is the I minus 1 JK, because I minus 1 we have the element in the I, and there are two gaps created in the J and K. Similarly, second is the J minus 1 and the I and K. So J minus 1, we will have the element J in the sequence of V. Similarly, in the third we have K minus 1, then we have an element of K in the sequence W, and the other two will be gaps. Similarly, we can use these and we can create the score delta for any of these ones. So this is the three-dimensional edit graph, and we can see here this is a point which is I, J and K, and we can see that from any of the vertices we can go to the main vertex I, J, K. So all we can see lines, they are merging at this vertex I, J, K. So this is the three-dimensional dynamic programming array S is created, and is easy to see that the recurrence for this S, I, J, K in the three-dimensional case is similar to the recurrence we have used in the Manhattan edit graph. So we can find the maximum value of the S, I, J, K by using the various options. As we have discussed earlier, that we have I minus 1, then it will be the score of delta plus Vi, and if we have J minus 1, then Jw, K minus 1, then Ku, and similarly we can use all of these options and we will get the maximum score out of these. So the option which has a maximum score, we will select that option.